All right, so what we're going to do is we're going to do some 4.4 style, AP style problems. Okay, so when you're doing these problems, this is a pretty common problem, by the way, to be on the AP test. And we're not going to do like the whole problem set. Do you remember how many points each free response question is?
8.
There's 9 total points. And there are 6 of these questions, okay? And do you remember how many points I told you you need to like shoot for each time?
9.
About half of the points. That's a good goal. Now, if you're like really wanting a 5, you probably need to shoot for more than that. But 4 to 5 points is a really good, like consistent 4 to 5 is great, okay? And so I'm going to kind of show you how you get your points on these as we go through as well. So when you see a problem like this, you see there's a graph of f, and then they give us a sentence. The graph of the function f is shown above. It consists of a semicircle and 3 line segments. Let g be this function, okay? And so what they're going to do is they're going to ask us all these questions about g, all right? But then they give us the graph of f. Does this sound familiar, where they ask you questions about one function, but then they give you the graph of another function? Yeah, we kind of already did this before, so some of this is going to sound familiar. All right, but what I would like to do is kind of write out a little legend, so to speak, over here, or a key that kind of puts out all the information out, so we don't have to keep saying, wait, what is this the graph of? What are we asking us again? It makes it's a little bit of work in the beginning, but it makes it really straightforward in the long run. So the first thing I want you to write is, what is the formula that they give you? Now, when I write this, I'm going to just write it as g equals the integral of f. Okay, so you don't have to write all the other stuff. It's just basically, here's the formula. G is the antiderivative or the integral of f. Now, since this is the graph of f, how do you integrate a function based on its graph? What do? You find the area between the curve and the x-axis. So I want you to write the word area off to the side. Okay, so anytime they ask us a question about g, like in part A, they're going to say find g of 0. What this is going to really tell us is, hey, you're finding area. So you're not having to like think through it again and again and again. Okay, the next thing I want you to do is to take derivative of both sides of this equation. So derivative of g would be g prime. What would be the derivative of the integral of f? Like, how do you derive an integral? What happens? It just is the same thing. Okay, so it's just f. So g prime is f. In other words, what they're really giving you is the graph of g prime. Okay? And since this is the graph of f, what these represent is the y values. In other words, on part A, they're going to ask us about g prime. That's the same as f. And so if I wanted to know, I'm not going to do this one yet because we're about to, but if I said, hey, what's f of 2? F of 2 would be 1 because it's the y value, because this is the graph of f. Okay? And then we're going to go one more time. There's going to be 3 total statements here. And the third one is going to be g double prime. We take the derivative one more time. And what would that equal in terms of f? Capital F would actually be this integral of f back here. Capital F is when we go backwards. So think, I'm just taking the derivative.
Is it the derivative?
Yeah, it's just f prime, the derivative of f. And since this is the graph of f, and if I asked you about f prime, what on the graph would you be looking for? So graphically, the derivative is the slope of the tangent line, right? And so I want you to write the word slope. So anytime we, like later on, there's going to be a piece that asks us about g double prime or f prime, we need to know that what it's really asking us about is the slope of this graph. Okay? Now this may have seemed kind of like weird, like why did we do all this? But I will tell you, if you do this, it saves you lots of time in the long run, and there's 3 problems in your packet. And in every problem you write, and it's almost the exact same. Now the letters, they may, like on another problem, use, instead of G, they may use H or something. All right? But you write the same thing down. Okay? You write down the statement that they give you, and that's area. You take the derivative, y values, you take the derivative again, and that's slope. Okay, so this is why we're writing the legend now. So let's actually get on with the problem. Okay, so for part A, they're asking for g of 0, and so I'm going to write this here, g of 0. And if you look at this, I'm given a formula, and I already know that when they ask me about g, it's area, so let's look at this integration. Okay, now I want you to notice that in place of x, I'm writing 0. The -3, though, is not something I'm making up. Okay, I'm not making up -3. It's just part of the formula that they gave us. So remember, graphically, what we're looking for is the area, and the area between -3 and 0. So you start at -3, and you go to 0, and what we're looking for is the area of this shape right there. Okay, now notice that that piece of graph is above the x-axis. So my integral, is it going to be positive or negative? Positive. Okay, if the area was below the x-axis, that number would be negative. Okay, there's another way you could get a negative, and that's if these numbers are switched, but we'll deal with that in a little bit, okay? So this is a trapezoid. So we find the area of a trapezoid by averaging these two sides. You know, we've already done this before with Riemann sums. So we're going to average 2 and 1, and we're going to multiply it by this distance, okay, which is 3. And so that turns out to be 9/2. That right there gets you 1 point out of your 9 points. So you really have to work hard for each point. Okay. All right, so let's do the next piece. So this was g prime of 0. So g prime of 0, if you look back up here at our legend, that's the same as f of 0. And which of these are we looking at in the graph? Area, y values, or slope? Y values. So this is what I'm saying. This really makes it clear. Oh, what's the y value when x is 1? What is it? Oh, I just gave the answer. When x is 0, the y value is 1. That's the answer. And that got you your second point. Okay? So it's kind of weird, but it's doable. We have the knowledge to do it. We just need to practice it. Okay, look at part B. Find all the values of x in the open interval at which g attains a relative max. Okay, so I'm going to write here, I'm going to say g has a relative max at, and I'm going to leave a blank, and then I'm going to say because it says justify your answer, and I'm going to do the justification first. Does this sound familiar, writing our justifications first? That's how we did it before. So what would the justification be for g having a relative max? Okay, so the slope, which would be g prime. So g prime is going to change, and if I draw this in the air here, here's a relative max. G prime is changing from positive to negative. All right, so let's go ahead and finish writing this out. So g prime, and what is g prime equal to? F. You need to write that, because you've always got to relate this back to f, because that's the graph that we're going to examine. G prime, which is equal to f, changes positive to negative. Okay? All right, so, and that's the y values. Again, this is where the legend helps us. So all you got to do is say, hey, where are the y values changing from positive to negative? So it's just an actual x value. It's like x equals, it's not going to be an interval. It's going to be an actual number. -4. All right, look at -4. I like that you brought that up. Look at how the y values are changing from negative to positive. So that's close. All right, -4 is not what I want, but it's close. X equals 3. Look at right here at x equals 3. The y values are changing from positive to negative. Okay? Do you see why we're not including 1 either? Because on 1, the y values are go positive, and then they just go positive again. So then my answer should be x equals 3. Now, I kind of left too much space, but that's okay. What would x equals negative 4 be? That would be where g has a relative min, okay? And so that could be an answer to a different question. All right, and so what happens here is you get a point for that answer, x equals 3, and you get a point for the correct justification. So how many points do we have so far? 4. Remember I said 4 to 5 overall is really good. All right, now we're going to skip part C right now. It's not that it's like too hard, it's just, it's a lot of work for 2 points, and there's a lot of chances for mistakes, and it's just not really the main part of what we're doing today, okay? So I'm going to skip part C. Usually in these problems, out of the 4, one of them is either a lot harder or you have to do a lot of work to get those points. So we're just going to skip C, okay? So let's look at part D, all right? Because part D is actually easier and less work. It says find all the values of x in the open interval of which the graph of g has a point of inflection. So again, I'm going to start it out by saying g has a point of inflection at, and then I'm going to leave a space, and I'm going to say because, and I'm going to figure out my justification. So what's the justification for g having a point of inflection? Do y'all remember? So g changes concavity. What else does that tell us? About maybe g prime or maybe g double prime.
G prime is a relative extrema.
So our justification could be that g prime has a relative extrema. We could write that. You thought of that, but I will tell you most students don't think of that connection. Where was anybody else thinking about g double prime maybe?
Well, G double prime is positive and negative.
When g double prime changes signs. This is where most students kind of think. So remember when you write g double prime, you got to write that it's equal to f prime. And we're going to just say changes signs. For points of inflection, it doesn't matter positive to negative, negative to positive. That doesn't really matter. It could go either way. So, and again, here's where the legend helps us out. That's talking about slope. So we're looking at where the slope changes. So look at right here, and I probably should be switching colors, but that's okay. Right here, at x equals negative 3, positive slope and then negative slope. It is a relative extrema of this graph. So that's one of my answers, x equals negative 3. Do you have any other answers? Remember, we're looking for the x values, not the y values, the x values.
Would 0 be a relative extrema or not?
So what do you guys think about 0? Is the slope changing signs?
No.
It's changing, but it's not changing signs. So 0 is not an answer. 1 and 2. And since we have these numbers and it's just a set, we'll put it in brackets. Although you could, if you wanted, do x equals negative 3, x equals 1, x equals 2. That would be fine. Okay? And that's how you get it. There's 2 more points right there. Basically the way, and did you guys notice it didn't say justify? So it would have been, if you had totally left this off, don't cross it off on your paper, but I'm just saying, if you had left that off, that's okay. It didn't say we had to justify it, so it's okay if you didn't. But the way these 2 points were allotted are, the way these generally go is if you have all 3 and you don't have any extra, you get the 2 points. Let's say you had accidentally added in 0, you would have only gotten 1 point out of the 2 points. And if you had maybe left off 1, you know, then they would allot you 1 point or 0 points, or depending on how they do it, okay? And so that's 6 points right there that we can get, all right? You really had to work hard for these 3. I'm not saying you couldn't do it. As we get closer to the AP test, we will not be skipping parts like this, but that's because this is more like what we're doing today. There's a lot of work we have to do on part C, and I'm just not sure I want to spend time on that.
Would the absolute minimum not be negative 4? Or is that just a relative minimum, or a relative minimum?
Negative 4 is a relative minimum, so what you'd have to do is you'd have to test
You have to prove
that relative minimum, and you'd have to test the endpoints, and you'd have to do all of that area. It's not really that bad of a problem, it just ends up taking a lot of time that I don't want to spend today. Okay, so turn the page, and what I would like for you to do on this one is first, notice that you're given another formula right here, and I want you to go ahead and write that formula off to the side, the shorthand version. And since this is the graph of f, what word should you put next to this?
G prime.
Area.
Okay.
Do you know what should go after it? Like if you take the derivative of g, you would get g prime. And if you took the derivative of this, you would get just f. And what word, or words in this case, should you put after that? Y values. So it's the same idea, and it's going to help you in the long run. And then the last thing you put is g double prime equals f prime, which is the slope. I promise you this is going to help you. Okay? I haven't always made students do this, and they tend to get confused. You may be confused anyway. I'll hand you that. This is not the easiest stuff. But without doing this, it's really confusing. All right. I want you to do parts A, B, and C. If you really want to do part D, go for it. That's fine. But I want you to do parts A, B, and C on your own. Okay, let's go ahead and wrap this up. It's been a long week, long day. So g of -1. Did you guys use the formula? What shape did you get when you looked at the picture? A triangle, right? Now, what's the area of this triangle? 3/2, right? Now, I'm going to say that the answer really is -3/2. And I want you to tell me why. Yeah, see these numbers right here? They're kind of switched up in the order that they should be in. It's going from 0 to -1. In other words, even though that shape is above the x-axis, we were going backwards. Okay, remember that first day when I told you guys how if these numbers aren't in the right order, you need to switch to them and put a negative? The bad thing about something like this is, okay, let's say you got 3/2. You didn't get any credit. You have to have the negative to get that 1 point. It's like 1 point or no points. There's no like half a point if all you did was leave off the negative. And I didn't warn you about that, so like I expected a lot of you probably wrote positive 3/2 on that. Okay, does that make sense why it has to be negative? What if it was going backwards and below the x-axis? What do you think would happen then? It would be positive again. Good. All right, what about g prime of -1? So f of -1, which was 0, as you should have been looking at the y value right there. Okay, what about g double prime of -1, which is the same as f prime of -1? Yeah, what were you looking at on the graph to determine 3? The slope. The slope of that line was 3. Very good. The slope of this line right here was over here was 3. That's how you answer that. Okay, now on the next one, look at how I set, actually the next two, look at how I set them up. If you were unable to do these, maybe just setting it up this way and then figuring out what to write could have helped you. So for part B, G increasing, I don't know where G is increasing, but I know my reasoning is going to have to do with G prime, which is equal to F, is what? Positive. So again, this is like one of those concepts we talked about last semester. So, and again, this is looking at the legend, this should be where are the Y values positive. So what's the interval? -1 to 1. If you wrote brackets there, that would be okay. Okay, you wouldn't get counted wrong. And I kind of stopped keeping track of the points, but each of those was a point. This answer was a point, the justification was a point. So go ahead and count up your points. Like how many would you have gotten? Remember, we're shooting for 4 to 5. So far you could have possibly gotten 5 so far. All right, so then on the last one, concave down, what's our reasoning? So G double prime, which is F prime, it's not changing signs. That would be a point of inflection, but actually concave down, it would be negative. Now, you could write this. You could say the slope of G prime is negative. That would have been acceptable. And so, and that is what we end up looking at on here. We look at where is the slope negative, which would be this interval. So what's my answer?
0 to 2.
0 to 2. And that's where you get 2 more points. 1 point for that, the answer, 1 point for the justification. All right, and so that was 7 possible points that we did, and we even skipped part D, which you maybe you could do and get points on. I don't know. We're not going to go over that today, though. Okay, so you turn the page and look at this next one. I want you to put an X through part C. You don't have to do that part unless you just really want to. This one is homework for you. And then we are also about to do a theorem write-up. In fact, I already gave you the purple sheets. If you can kind of pass those back. We're going to do 2 theorem write-ups. We're going to do one on the fundamental theorem of calculus. And my goal for you is that you finish this and turn it in before you leave. I think you have enough time to do that. And then the second one you're going to do on the back is the mean value theorem for integrals.